Welcome back. We are continuing our work on the tutorial. This time we are continuing on factorizing. On this topic, this is very cheap topic that I will keep this session as brief as possible. I'm not going to drag it on for a long time. And in fact, there is a reason for doing that. The fact that at this time you are doing the advanced level mathematics indicates that you are more able and well equipped with some basic algebra. However, I'll be very precise in the detailed work when it comes to some complex and challenging topics. In those ones, I will definitely take my time in detailed explanation of whose one of those examples, like example like quadratic function and its graphics. They are very much important, quadratic functions and the graphics thereof. So I will take much time to explain to make a detailed explanation, because honestly, it will be very hard for mainstream school setting, to go in depth of detailed work as we will consider, because of time propensity. Teachers and lecturers in main school settings, they may not have time to go into such in-depth details, which in this tutorial, when we come to topics like quadratic functions, we will do it. We will treat them into much details. And not only that, the rest, the complex ones, as I've said, the complex ones, we will deal them into much more details. By the end of the tutorial, and by the end when you're about to take your exams, you find out that, you are more able, and your skills in attempting even crazy questions will be amazing. This is it, and this is all what we're about. So at the moment, let us start by, as I've said, this session is not going to be dragged on. We are just brushing up some things. Okay, let's start with this one, for instance. Factorize. Factorize. 1. 5 x plus 25. 2. 16 s squared y plus 4y. 3. S cubed minus 3x. Good. Starting with the first one, which is 5x plus 25. This is no different from 5x plus, what is 25? 5 times 5. You have 5 here, you have 5 here. You can factorize the 5 out. So it becomes 5 outside the bracket x plus 5. Bam, bam, we're done. Then we come to the second one. The second one, that says that 16 s squared y plus 4y. Good. 16 is equals to 4 times 4 s squared y plus 4y. This is no different from 4y times 4x plus 4y. You have 4y here. This is x squared, yeah. You have 4y here, you have 4y here. So you can factorize the 4y out. So it becomes 4y outside the bracket. 4x squared plus 1 plus y plus 1, yeah. Yeah, this is it. Then the third one says that x cubed minus 3x. This is no different from x multiplied to x squared minus 3x. You have x here, you have x here, you can factorize the common factor out. X outside bracket, x squared minus 3. Bam, bam, you are done. Good, so simple. And this is something that, as a matter of fact, we are not going to spend the whole time for this. I mean, this is, just the basics. More probably, it is just a recap of those things that you did in the O levels or the GCSE. Good, good, good. Let's move on. Okay. Yeah. This one, we have factorization of quadratic equation in the form of ax squared plus bx plus c, where a, b, and c are real numbers. Okay. At this point, this is what we are going to consider. Factorization. Factorization of a quadratic equation in the form f of x is identical to ax squared plus bx plus c, where a, b, and c are real numbers. Good. Before we proceed on, there is something important that I want you to know. If you have any expression like this, number one, like this, x squared minus y squared, we call this as a difference of two squares. If you have any expression like this, it is no different from x plus y, x minus y. It is very common. Such kind of expression is very common in partial fractions. And there are some integral analysis, some integration that this type of expression, difference of two squares are involved in it. So if you have something like this, The right hand side is the identity. So x squared minus y squared is not different from x plus y into bracket multiply to x minus 1 into bracket. We call this one difference of two squares. Difference of two squares. Similarly, if you have a s squared minus b s squared, it is also not different from a squared b squared, this one. It is not different from as plus b multiplied to as minus b. This is it. For instance, if you have something, a typical example of this identity is, for example, 4s squared minus 25y squared. This is not different from, this expression is not different from 4 squared is equals to 4 is equals to 2 squared multiplied to s squared minus 25 is 5 squared y squared. This is not different from 2x plus 5, 2x minus 5. It's very, this identity is very important, and it is something that, you should have the manipulation thereof. You should have them on your fingertips. Okay. Then take your time to copy as we prepare ourselves for the next question and analysis. I think there must be, I did a little bit mistake over here. Let me put here y. So this one becomes by. Yeah, a squared s squared minus b squared y squared is not different from ax plus by in the bracket multiplied to ax minus by in the bracket. Take your time to copy. There is also another example that says that, for instance, if you have 16 s squared minus 9y squared, this is not different from, you can make this one (16) is 4 squared s squared, 9 is 3 squared y squared. Okay, this is not different from 4x plus 3y, 4x minus 3y. Good. Let's take another example. If you have s squared minus 9y squared, this is not different from s squared minus 3 squared y squared. which is no different from x plus 3y multiplied to x minus 3y. You know, this one is also very common in integration. In A2 integration, it is very common. So it is something that it is worthy of notice. Okay. In that same vein, for instance, if you have let's say s squared minus 25 y squared, by recognition, you can say that this is equals to s plus 5y x minus 5y. This is it, the same. Good. As I've said, we are not going to spend too much time on this, and we'll move forward. Take your time to copy we prepare ourselves for the next one. The next question is just a recap of what you already know from GCSE or O levels, ordinary level. You know this from the GCSE. Factorize. S squared plus 5x plus 6. If you have something like this, you already know it from the GCSE. It is not a big deal at all. So we are not going to spend too much time on this. But if we move further, and then we will spend time for detailed analysis. Okay. This is no different from a s squared plus bx plus c. If you compare the coefficients, you can see that this one is also the same as 1. So a is equals to, comparing coefficients, comparing the coefficients, we observe that a is equals to 1, b is equals to 5, and c equals to 6. Very good. If you have a quadratic equation like this, you always multiply the coefficient of s squared to the constant. Always. The coefficient of s squared, the coefficient of s squared, which is a, always multiply to the constants. So if you look here, the coefficient of s squared is 1. If we multiply it to the constant, we have 6. Then we are going to deal with 6. So what I do is that 1 times 6 is equals to 6. But in general, 6 is also equals to 2 times 3. 6 is also equals to minus 2 times minus 3. 6 is also equals to 6 times 1. All these are possible. Multiplication of all these are possible. Will give you a possible 6. But we are interested in a specific one. If I take this one, for instance, 6 times 1 is equals to 6. But if I add them, it becomes If I add this one, it becomes 6 plus 1, which is equal to 7. Now, you check. Is the coefficient 7? No. Therefore, this one is ruled out. If I add this one, if I add this one and this one, it becomes minus 5. Is the coefficient of x minus 5? No. Then we rule this one out. If I add this one to this, I'll have 5 plus 5. Is the coefficient of s plus 5? Yes, which indicates that this, in fact, this is the factor. Therefore, it becomes s squared plus 5x plus 6 is not different from s squared. You see, 2 and 3 are the factors. It becomes s squared plus 2x plus 3x plus 6. By any means, you can see that if you add 2x to 3x, you have the 5x that is there. So you can see that the left-hand side of the equation is exactly equal to the right-hand side of the equation. This is it. So we are going to apply the factorization, that we practiced previously. This one and this one, I can factorize x outside. So it becomes x plus 2. Good. When I have x plus 2 like this, I will expect that I will expect to have the same thing here. So you can see that x plus 2 as well. X plus 2 as well. What I have here, I will impose it here. Whatever I have here, I'll always impose it here. When I impose it here, then I begin to contemplate what to do so that what has been imposed here can be identical to this one. Of course, this can be identical to this one if I multiply this by 3. So you can see that by any means, if I multiply 3 to x, it will be 3x, which is this one. And if I multiply 3 to 2, it will be 6, which is this one. So whatever I have here, I will always impose it here. And then algebraically, I will find something, that will, correspond, a coefficient that will correspond, to this one. So you can see that this one becomes x. But you see, assuming this is the left-hand side and this is the right-hand side, you can see a common factor, which is x plus 2 at the right and x plus 2 at the left. So that common factor, s plus 2, I factorize it out. And then I'm left up with x plus 3. So in this case, this quadratic equation that you see there becomes s squared minus 5x, plus 5x plus 6 is not different from x plus 2, x plus 3. This is it. Good. Take your time to copy. Anyway, this is a video, So at any given time, you may like to pause it while you go through, and then you can copy it later on. Let's take this example, which says that x squared plus 2x minus 3. Outside there is a bracket, there is outside the bracket there's x. Well, this is no different from if you have an expression like this. You first have to concentrate on this one. So we are going to concentrate on this one. If you have an expression like this, you can see that the coefficient of x squared should be multiplied to the constant. X squared as it stands, the coefficient of x squared is 1. So you multiply 1 to the constant. So if 1 is being multiplied to the constant, we have 1 times minus 3, which is no different from minus 3. But in general, minus 3 is equals to minus 3 times 1. Minus 3 is equals to minus 1 times 3. If I add minus 3 to 1, I'll have minus 2. If I add minus 1 to plus 3, I'll have 2. Then I compare. Is the coefficient x minus 2? No. The coefficient of x is plus 2. Therefore, I rule this one out. Is the coefficient, this is 2, is the coefficient of x plus 2? Oh yes, this is plus 2. The coefficient of x is also plus 2. Therefore, this is correct. In that case, minus 1 and plus 3 are the factors. In that case, this expression, x squared plus 2x minus 3 is not different from x squared. I'll call this one equation gamma, equation alpha. Good. We'll come back to it. X squared plus 2x. But we know that the factors of plus 2x is the same as minus 1 plus 3. So it becomes minus x minus 3, minus x plus 3x, then minus 3. The left-hand side quadratic equation is no different from the right-hand side quadratic equation. Why? How? If I add minus x plus 3x, we will have plus 2x, which is the same, and everything is the same. At this time, I'll factorize x outside. So by using this one, so I'm going to factorize x outside. X, then I have x here minus 1. This expression that I have here, I will make sure to impose it here by force. So I have x minus 1. Then, if I multiply plus 3 here, by any means, it can be 3x minus 3 if I multiply. Then, you can see that this side and this side, they have a common factor, and that factor is x minus 1. So because the factor x minus 1 is common here and here, we will factorize it out. So it becomes x minus 1 being factorized out. Then we are left with x plus 3. Therefore, s squared plus 2x minus 3 is identical to x minus 1, x plus 3. I'll call this one equation beta. Good. Good. Let me borrow this section. I'll call this section section 1. And let me borrow this section and call this section section 2 as we continue. You see, if we put equation beta into equation alpha, putting beta into alpha, putting equation beta into equation alpha, we will have s squared plus 2x minus 3 multiplied to x, where we see that s squared is equals to x minus 1, x plus 3. Therefore, it becomes s squared plus 2x minus 3x is identical to x minus 1, x plus 3x. Yes, that's it. Take your time, copy it, and we will continue. Or you can pause it while we prepare ourselves for the next question. We are taking another question, very much similar to the one that we considered. Yeah, this question says that factorize two s cubed minus s squared minus 3x. Solution. Two s cubed minus s squared minus 3x is no different from 2x, there's x here, x here, x here, so we can factorize it out. Come 2s squared minus x minus 3 And this one is a quadratic equation in x. As I've said, always multiply in dealing with such analysis, always multiply the coefficient of x squared to the constant. So, if we multiply the coefficient of x squared to the constant, we are going to have 2 times minus 3 is equals to minus 6. Good. But minus 6, bad. Also, minus 6 is equals to minus 6 times 1. Minus 6 is equals to, is also can be also equals to minus 3 times 2. Minus 6 can also be equals to minus 1 times 6. Good. Okay. Let's try to add minus 6 to 1. So minus 6 plus 1 is equals to 5. Is equals to minus 5. Is the coefficient of x squared minus 5? No. Therefore, this one is ruled out. Good. This one, let's try to add minus 1 to 6. So it becomes minus 1 plus 6 is equals to 5. Is the coefficient s of x 5? No. Therefore, this one is also ruled out. Then let's get to this one. Let's try to add minus 3 and plus 2. Minus 3 plus 2 is equals to minus 1. Is the coefficient of s equals to minus 1? Oh, yes. Then this one is a factor. So we pick up minus 3 plus 2. So this one becomes s equals to 2s squared. Then we use the factor minus 3x plus 2x minus 3. Good. Then I will need a section, so pardon me. It was just for explanation, and I think you may pause the video. If you need to copy it, you may pause the video to copy it. But at this time, I will borrow this section because we need a place. Good. Then we are dealing with this one at the moment. So first of all, let's deal with this one by factorizing x outside. So it becomes x 2x minus 3, then plus 2x minus 3. Good. We can see that already this one has been already imposed here. So we can algebraically, we can say that x, the whole bracket, x 2x minus 3, which is this one, plus manipulation. We are manipulating it. 2x minus 3, which is the same. Because by any means, if I multiply this one to this, it's still the same. So you can see that at this particular side, there is a common factor that is 2x minus 3. And on this side, 2x minus 3. So the common factor, we are going to factorize it out. So it becomes x, which is this one, x, we are factorizing common factor out, which is 2x minus 3 plus, x plus 1. Good. This is multiplication. Don't be confused with it. So we can see that we have x, 2x minus 3, x plus 1. Therefore, 2x cubed minus s squared minus 3x is identical to x, 2x minus 3, x plus 1. So simple. Good. Take your time to copy everything as we are preparing ourselves for the next question. We are going to consider also another important question that says that factorize, possibly I'll write it here, factorize eight x raised to the power 4 plus 10x squared minus 3. If you are given equation like this, it is still not a big deal. I would say that solution put or before that I have a plan. This equation 8 x raised to the power 4 plus 10 raised to the power s squared minus 3 is no different from 8 raised to the power square also square plus 10 s squared minus 3. Okay. Put s squared equals to y. In this case, we have this expression becomes 8 put s squared equals to y. So s squared, we put y there. And then we can see that square plus 10 x squared, we'll put y there, minus 3. So this one becomes 8y squared plus 10y minus 3. As I said, this is a quadratic equation in y. It has been transformed to a quadratic equation in y. To deal with this, you always have to multiply the coefficient at this time of y squared, or the coefficient of y squared, you multiply it to the constant. So if you multiply the coefficient of y squared to the constant, it will become 8 times minus 3, which is 8 times minus 3 is equals to minus 24. And let's see. In general, minus 24 is no different from minus 6 times 4. Minus 24 is also no different from minus 12 times, let's say, 2. Minus 24 is also no different from 12 times minus 2. Minus 24 is also no different from minus 8 times 3. Minus 24 is also no different from 8 times minus 3. You can go on and on and on until it becomes exhausted. But let's try with these ones. If I add this one to this one, adding this one to this one, it will be minus 6 plus 4 is equals to minus 2. Is the coefficient of y minus 2? No. Therefore, this expression, I don't need it. Then let's come to this one. Let's come to this one. Minus 12 times 2. If I add them, it becomes minus 10. If I add minus 12 plus 2, I will have minus 10. Is the coefficient y minus 10? Oh no, it is plus 10. Therefore, this one is ruled out. Then let's try this one. Let's try this one. If I take this one, 8 plus minus 3, I will have 5. Is the coefficient y 5? Oh no, this is ruled out. We don't need it. Then let's try this one. Minus 8 times 3. If I add minus 8 to 3, I will have minus 5. Is the coefficient y minus 5? Oh no, we don't need you. Now, let's get to this one. Adding 12 to minus 2, it will become 12 plus minus 2 is equals to 10. Is the coefficient y plus 10? Oh yeah. Then this one, we take it. The factor comes from this. So we pick it straight and it becomes 8y squared plus, the factors are 12 and minus 2. So we have plus, we have plus 12 y minus 2y minus 3. Good. Or can do it this way or that way, whichever. So let it stay like this. So at this time, I'll pick up this one and factorize it. I can see that I can tell 4y is a factor here and it is also here. So I'll factorize 4y outside, and then I have a 2y. Then I have plus 3. Good. Very good. So by any means, 4y times 2y is equals to 8y squared. 4y times plus 3 is 12y. Okay. This one that I have here, I will impose it here. So me trying to impose this one here, it becomes 2y plus 3. But we have minus 2y minus 3. Then why don't I make here 1 times minus 1 times this one? So by any means, minus 1 being multiplied to 2y, it will be minus 2y. Minus 1 being multiplied to 3y, it will be minus 3. So you can see that there is identical factor here, which is 2y plus 3, and which is 2y plus 3 as well. So I will then come to factorize it. So you can see that we don't need this one again. This one is no longer needed. So we will take back our space, since every little space matters. Very good. So factorize the common factor out. So we have here is equals to 2y plus 3 being factorized out. Then we are left there 4y. Good. Minus 1. Good. So therefore, eight y squared plus 10y minus 3 is very much identical to 2y plus 3, which is this one, 4y minus 1. Good. I'll call this one equation alpha. But earlier we put s squared equals to y, reinserting which indicates that x raised to the power 4 will be y squared. So s squared is equals to y, and s raised to the power 4 is equals to y squared. Putting them back into equation alpha, we'll have 8 y squared is x raised to the power 4 plus 10y, or this y is equals to s squared minus 3. Then we come here. What is then we have 2. What is y? Y is equals to s squared plus 3, 4. What is y? Y is equals to s squared minus 1. Therefore, the left-hand side, 8 raised to the power of 4 plus 10 squared minus 3 is very much identical to the right-hand side, which is 2s squared plus 3 into bracket multiply to 4 squared minus 1 into bracket. So, this, with all reasonable of certainty, the left-hand side is equals to the right-hand side. Take your time to copy it as we prepare ourselves for the next question. The next one that we intend to deal with, is different.